Okay, so we have reached the final talk for the day. No pressure, Chris. Fireworks, 3D illustrations, complex algorithms, you name it. This is Chris from Cambridge, and I also think this will be a very interesting talk. So again, no pressure, and good luck, Chris.
Thank you, Ben. And actually thank all of you. It's been really great for the last couple of days hanging out with you guys and hearing some really interesting stuff. So as you just heard, I'm Chris. I'm working with Denise and actually another 4 people, so 6 of us on the Pico project. Yeah, so like we said, we want to try and replace passwords. We want to try and make something that's actually better. And so to do that, we kind of break all compatibility. Kind of like clean slate. What if we could do this? What if we could just start again? How would we get people to authenticate? And so our current thing is dedicated device. That's really off-putting. Dedicated device, capable of replacing as many types of passwords as we can, and eventually release it as an open standard with a really decent reference implementation that anyone can build, both on a server side and an actual device. So rather than having to remember tons of passwords, Pico remembers your secrets for you. I'm not actually going to be talking that much about Pico, so if you're keen to know, feel free to ask me about it, or just go and Google one of Frank's previous talks or his paper, which I think expressed the kind of concept of the idea quite well. So today, I'm actually going to tell you a little story, because I thought that would be a nice way to frame it, about a made-up person called Jess, and how some things that rely on visual codes for authentication are really quite broken. So, in this kind of scheme, when Jess wants to log in, she scans a visual code with a trusted device. Inside this visual code, identifies the service, like her webmail in this example, and also the terminal that she wants to use for the session. By doing this, what we can do is never reveal a long-term secret to the terminal, which in an environment where your terminal most definitely has malware on it, that seems like quite a good thing. She also only needs to unlock one device rather than having to remember a secret for every single service. Her device then goes away and by a separate channel mutually authenticates with the service. And then instructs the service to allow the terminal, which was identified by the visual code, to log in as her. Ta-da. There's a really big fundamental issue with this. And it's that, basically, that I can convince you to scan a visual code which will log my terminal into your account. So I can convince you to scan a visual code which will log my terminal into your account. Well, how can I do this? Imagine a world where this kind of scheme might have caught on. So I could run or compromise a different service, let's say a blog of this conference or something. And I simply just lift the visual code, put it in my page. If Jess wants to log into my blog and to comment on something, she just scans the code, and that logs me into her Google account. Because all I've done is taken the thing which is going to authorize my terminal and given it to her, and she scanned it for me. So to sort of fix this, some people have suggested that Jess should check the URL of the website, and that matches the identity verifier. So she gets a confirm screen like this one, which is from a paper from Stanford called Stamp to Pass, which is described a scheme like this, with a big colourful logo. And we all know this type of thing doesn't work. People are really susceptible to phishing. Most people will just learn to click yes without really looking. And even if the user is well trained, if we combine this with regular phishing, they're really in trouble, because if they can't identify the website either. So all I do is address up a fake Google login page, lift the proper visual code, and put it in that. And at this point, she has to check the identity of the verifier on the terminal, and the HTTPS is being used, and the identity of the visual code authenticator. So this type of system is not resilient to phishing at all. Actually, it's even harder for the user to defend themselves from phishing. And I mean, I could even say email her a QR code saying, I'm from your bank, to validate X or Y or Z, scan this visual code. And obviously you can defend about that kind of thing by maybe having a time limit on it. But none of these things fundamentally change this issue. So let's step back for a second, and I've described a problem of systems that don't really exist yet. And we kind of thought that too, because we built a system designed to show the usability aspects of Pico without doing any crypto or anything like this, and kind of spotted, oh yeah, that's a really stupid design decision. Then we spotted something called Squirrel, which is an attempt at an open source project which does exactly the same thing. And there's a sample stats class. There's another research project in the Netherlands called Ticker, as well as also some freeware and commercial ventures into this area. If you just Google QR code login, loads of people are making this mistake. So I was going to go into a little bit more detail. But actually, I'm not criticizing necessarily the implementation of these systems, more their fundamental architecture, because the implementations are quite variable, they're researchy. But actually, I want to argue that the fundamental architecture of embedding a challenge in the QR code is just a completely flawed concept for the area of web authentication. So in my helpful, exciting diagram, we have a website offering a service, the web browser user, and their visual code authentication device, which could be a mobile phone, it could be their Pico, it could be some other dedicated hardware device. Doesn't really matter for this kind of purpose. So the user requests a login page from the website, and then the response includes the identity of the authentication service, so maybe a public key or something, or just a URL, and some sort of session logs, which is fresh. This information is displayed in the web browser. The user scans the QR code, and then this starts up an authentication session. So to make things clearer, I've kind of split off the website and shown you a separate authentication service. So there's some sort of authentication protocol, varies a lot in how they do it, but somehow in that, the visual authenticator sends an authenticator user ID and the session logs to the authentication service. This then internally instructs the website to allow the user to log in. At this point, we've got this kind of square going on. The web browser knows nothing about anything that's happened so far. And in all of these schemes, what happens next is the website presents the session logs, which has sort of implicitly become a one-time password or a capability, depending on how you want to look at it, to log into that account. And then we get a session cookie like we do in a normal session, and everything continues as if user username and password, it's all the same. And we could try and automate this sending of a session logs by perhaps having like a poll listening or something like that. But I don't think that really fundamentally changes the way the system works. So how do we attack this? Right. So we have a pretty standard man in the middle coming up here. So the man in the middle requests the login page, relays it to the user scans the code. Then the visual code authenticator knows nothing about this relaying and just goes through the separate channel straight to the valid authentication service. That instructs the website to allow the user to log in. The attacker then presents their credential and gets logged in. Is that kind of clear? It's deliberately done as like really similar to the other diagram to make the point this isn't a particularly complicated attack to mount. So why do I think this is vaguely important? Because a man in the middle like this can break loads of current authentication schemes, depending on whether you have HTTPS with, HTTPS will be fixed things, but not everyone uses HTTPS, and we have to talk about session hijacking and all that kind of thing. But the reason this is perhaps worse for this kind of system is that we've essentially made a device that can be phished. We've made a device that automates the process of the user being phished for them. So assuming people are not going to reliably check that their session is using HTTPS and that their identities all match and all that, what on earth can we do? So some people would suggest we display the visual code in a trusted environment, so like a browser plugin or something. But again, users are easily fooled. There's a phishing study, where was it? Why phishing works, where a good phishing site convinced 90% of the general public that it was a genuine site. So trusted visual code display, unlikely to actually work in practice. Another thing we could try is trying to bind the location of the two things. Some people suggested that. The problem is that it's basically impossible to check when we have an expected mismatch. So, for example, if I'm using the Wi-Fi here, but my phone is my visual code authentication is on a mobile network, there's going to be a location mismatch. I'm not going to be able to pin down the GeoIP. And actually, stuff like GeoIP is only has a 15% gets 15% locations wrong. Not even that it doesn't know 50% locations, it actually gets 50% locations wrong by 40 kilometers. So either we end up blocking loads of legitimate logins or allowing some bad ones through, which clearly isn't a proper solution. So maybe in the realm of slightly better ways of fixing this, we could use a secure bookmark on the authenticator. And this has been suggested in several academic papers, such as one called foolproof phishing, which I recommend you read if you haven't. Which essentially means you select the account you want to log into on the device first. And that fixes this issue, but at a price, we now have to have a quite big UI on the device, which maybe if it's a smartphone doesn't really matter, but if it's a dedicated hardware token will make it a lot more expensive or difficult or annoying to carry. And we also need a secure channel from the device back to the PC that we're hopefully reasonably confident is not being relayed. However, one of the design goals of Pico is to have distance bounding or some approximation of distance bounding between your Pico and the terminal. So actually we already need this secure channel, so maybe that's less of an issue. But if we actually use the visual code still, but we use it just as an index into the database of credentials, so we just use it as a service identifier, rather than embedding a challenge, this problem kind of goes away. So the user scans the code, which triggers this mutual authentication, exactly the same as before. But instead now, the service can just hand, rather than have the browser having this sort of one-time password capability, that's handed to the visual code authenticator, which then hands it over this hopefully unrelayed channel to the terminal. So the terminal can be logged in. So you can see that this isn't, I haven't sort of spotted the easy answer to fixing this. We're fundamentally changing the architecture. And obviously this is a complete pain because we need to modify the terminal to work with it, so we need extra, maybe even hardware and software on the terminal. We also need our visual code authenticator to work with that, and we need somehow to set that up. So we thought, actually, as a fallback, there's no reason that such a device couldn't present the user with a one-time password. And actually, if we present it as a URL for them to type in the web browser address bar, they might even not be phished too easily, although perhaps some people will just Google their capability. But so we actually have sort of two parallel solutions that you can use, one of which sacrifices deployability, another one of which sacrifices usability for the sake of each other.
Chris, have you lost your mic?
Oh no, I'm really sorry. I just screwed up the recording.
Probably okay.
You'll have a really loud, like, sort of last few minutes of my talk. Sorry about that. That was really stupid. But yeah, actually, that's all I really have to say. So yeah, thanks for this. I mean, I didn't want to sort of go really, really deep into the detail because I don't think it's actually it's the architecture that's much more interesting than the ins and outs, because we've sort of gone through a fine-tooth comb with all of these schemes, double checking that they're all actually vulnerable to this type of attack, even though they all are wildly. Oh, sorry. So there you go. There's my list of possible solutions. And we want to add this fallback mechanism, so we maintain the ability to authenticate if you just turn up and want to use a machine. So, any questions? And thanks for listening.
Well, as soon as they announced Squirrel, I guess other people as well got a lot of questions about, do you think this is good? And I read it, and initial thought is, yes, they do solve a couple of problems and it is good, but it also took like 24, 48 hours before somebody put out a tweet saying that you can still do the relaying and you know, man in the middle attack on Squirrel as well. But the reason for why you are saying that it's broken, it's not good enough, is that only because of that it can be man in the middle attacked, or or some other arguments as well, like into usability and psychology for that. That makes Skrill not a good solution.
I think Skrill is probably not the best example because they've got some very bizarre uses of like crypto constructs and stuff like that at the lower level. There's a wonderful thing actually. It has a revocation protocol that sort of abuses Diffie-Hellman in such a way that the website has a secret, which holds a secret in plain text, which is your revocation key, which you then regenerate on your device with something you kept offline. So if someone hacks the website and gets the password list, they can then request revocation on everyone's account. So there are lots and lots of problems with such schemes. There are problems with usability in such schemes as well. I mean, wouldn't say I'm a massive expert, nor do a lot of them have decent implementations to actually try out. One thing is, how long does it take you to, say it's on a phone, how long does it take you to pick up your phone, scan a QR code with the application, select an account, maybe if you've got a choice, and then for all of the back-end stuff, maybe that will only take a few seconds. But you might even be talking about 30 seconds worth of authentication, which is enough to completely interrupt whatever task you're actually trying to do.
And you have to unlock your phone first as well.
Yes.
Yeah, I mean, yeah.
So one of the things that we want to not do in Pico is to try and reduce that. One of the thoughts is if I walk away from my machine with Pico, the distance bounding will obviously break and it will lock the machine. But if I come back within some certain configurable amount of time, there's no reason why it can't just unlock again. And obviously people have done this kind of stuff before, and there are flaws like, oh, I walked past the wall of my office and my computer unlocked. But trying to actually reduce the number of times the user has to authenticate is probably quite useful. And also pushing authentications out from the task you're trying to do. If you sort of start something and then have to authenticate halfway through, it's very disruptive to actually getting things done and very irritating. Whereas actually, if you have to do it between some sort of subtasks, it's actually more acceptable. There's some research in that area as well. Surely Denise will actually give you better answers about this kind of stuff.
Ask the question again?
What's the usability of these schemes like, basically?
Oh, all schemes, not just Pico.
Well, having to scan a visual code versus having to type a password.
I wasn't convinced until I actually used it, and then I was surprised that when you're actually pulling the device, out of your pocket or whatever, you don't think of that as taking time, but the actual taking a picture of the QR code takes almost no. I was just surprised at how quick it was when I did that. So I would say what's more important is the perception of time, not the actual amount of time. So when people are doing stuff, they perceive time to be shorter than the time it takes to be shorter than what it actually is. So for example, at self-service checkouts, we have them in everybody's country here. Self-service checkouts. Anyway, they don't actually take much less time than normal checkouts, but they feel like they do because you're involved in the whole process. And so some people are more satisfied with it saying it's quicker when it's not actually that much quicker at all. And so the same might be the case with Pico, in that you're making an effort to take a picture of the QR code, and then you're immediately, as far as you know, the only waiting you've actually had to do is between taking the picture and being signed in. You're not actually thinking about everything in between. You take out your pocket, you line up and take a picture. Do you see what I mean? Does that answer your question at all?
I think there's also a comment.
Yeah,
Oh,
it
sorry.
does. Yeah.
There's also a comment to make about the sort of cognitive load on the user. If it's, oh, I need my password, oh gosh, which one was it? Have I got to 13 or 14? As we saw that a couple of talks ago. Whereas this at least doesn't require you to recall anything. Or then again, there's the whole authentication, something you know, something you have, something you are, is always something you've forgotten, something you've lost, and something you once were. So
Something you will never be.
We had an interesting discussion with someone saying that actually, I think it was 15% of their IT help desk time was taken up with password resets, but about 7% was taken up with people who'd forgotten hardware tokens, like door entry cards and things. So there is a danger with this kind of thing of forgetting your password. Well, maybe that only affects one thing, but if you leave your hardware authenticator that authenticates you to everything at home or on a bus,
Did
you-
that take into account the preference of other tokens versus passwords?
Yeah, that's true. Although I would say you have got quite a lot invested in a Pico if you've got authentication, if you've got pairings as such with loads and loads of different accounts.
Yeah.
Although you hope that at least it can't be stolen if you have a decent unlocking mechanism, or it is, well, it can be stolen, but at least they don't gain all your credentials.
More questions, comments? Nicola?
I don't see exactly the advantage of using that solution rather than, let's say, two-factor authentication. What is
So
the advantage of using that?
the advantage of using, say, as a trusted device with secrets on it versus two-factor authentication.
Because let's say you have Google Authenticator on your mobile phone, so it's quite the same.
Yeah, it's not a dissimilar concept, although one of the goals of Pico is to see whether we can actually do this without you having to remember any secrets at all. Does it still work? Do we have reasonable assurance of security, well, depending on how you want to define your threat model, that you can revoke it if it's lost or it's not useful to someone to steal it? So yeah, no, it's not hugely different. And also you can talk about how it compares to things like single sign-on schemes. One nice thing about this kind of concept is that the trusted third party is your device. It's not sitting out there on a server somewhere. Because the problem with the two-factor authentication is that if you're still saying, oh, I should probably use a different password everywhere, you still have all of these passwords to remember. You haven't solved that problem. But you're right, there are interesting parallels to draw. I don't think it's like completely revolutionary design space, but it's kind of trying to push the boundaries of what a hardware token could be.
Okay. Well, thank you, Chris.